Going on, Alex Bros? In this video, I'm just going to touch on a couple of items regarding the formula for compound interest. In simple terms, compound interest is interest upon interest. So as we saw in that introductory video, throughout each year, interest can be charged a fixed number of times. If we're compounding interest quarterly, then throughout all the years for which the loan is active, um, each year is going to have four interest calculations. And remember, each calculation of interest is based on the most recent calculation of interest. So there's sort of this layering effect, hence the expression interest on interest. And basically, compound interest will eventually beat out simple interest just due to the way that the arithmetic works when formulating it. The formula for compound interest given here is A equals P times quantity 1 plus R over N raised to the power of N times T. So this is a formula that is exponential in nature, which is why we're seeing it in this chapter, studying the chapter on exponential functions and log functions. And the A in this problem stands for the final amount. So what this formula does is it helps us figure out how much would be owed at the end of a loan, for instance. So if you take out a loan, and it's the interest is compounded, or the interest is compounded, or in other words, compound interest is being used. This would give us an idea of how much we owe at the end of the loan. P stands for the principal, which is the starting amount. So if you took out a loan of $2,000, that would be the value of P. And R stands for the rate, which, keep in mind when we do our work with the value of R, we want to convert it back into an ordinary number versus a percent. So I like to say use the decimal version of the annual percentage rate that they give you. And N stands for the number of times per year the interest is compounded. So I want to talk a little bit about the format of this formula. On the right-hand side of the equal sign, we're seeing the variable P standing for the initial amount, or the principal. And then right next to it, we're seeing 1 plus R over N. And so what the 1 does for us is it takes into account the most recent interest calculation. And then what the R over N represents is the actual interest that's the actual rate that's being charged on the account at each time the interest is calculated throughout the year. So in that introductory example, we had an interest rate of 8%, but since it was being compounded quarterly, in reality, each time interest was being charged, it wasn't being charged at 8%, but rather it was being charged at 2%. And the N times T up here is really just a matter of counting. So if we had interest being calculated quarterly and the loan was out for 10 years, then there would be a total of 40 interest calculations, and that comes from basic multiplication, 4 times 10. So the N times T takes into account how many total interest calculations there are throughout the number of years that the loan is good for. Now, in most of these problems, we'll be able to utilize the compound interest formula. There's going to be another type of interest we discuss called continuous interest, but you'll know to use compound interest when you see some key words, which also correspond to specific values of n. So for instance, if somewhere in the problem it says compounded annually, then you're going to use compound interest, the formula for it, and the value of n to use in that case is 1. If it says semi-annually, then it means that interest is charged after every half year. So since there are 2 halves of a year in a complete year, n would be 2. Quarterly would correspond to 4. Monthly would correspond to 12. Weekly, 52. And then daily, 365. Now, with some institutions, daily might be 360 or some value less than 365 due to things like holidays and such. But this is it for the video regarding the formula for compound interest. In the videos to follow, we'll look at some specific examples which use some specific values. All right, so as always, if you have any questions regarding the content of this video, feel free to reach out. Otherwise, thanks for watching, and I will see you in the next one.